students. Today like to take a little bit of time to go over the concept of positive and negative motion in physics, specifically as it relates to velocity and acceleration. Now, as a quick recap before we get started, let's start with the basic concepts of velocity and acceleration. Velocity is the measurement of distance traveled over time, and it is a vector quantity, which means it has a direction. So whenever we're discussing velocity in the point of view of physics, we need to indicate what direction we're moving, whether it's positive, negative, or we can say left, right, up, down. If we're at an off angle, we can say at 45 degrees. Whatever is based off of our frame of reference. Now, looking at the screen, our frame of reference here, we're going to set our frame of reference to be that any motion to the right is positive. Any motion or force applied to the left is negative. Now, part of the reason for this is there's a lot of misconceptions, specifically when it comes to acceleration, as to what this positive and negative mean. One of the most common misconceptions is that if an object is slowing down, it must be experiencing negative acceleration only, and if it's speeding up, it must be experiencing positive acceleration only. Now, this is incorrect. And just as a reminder, remember the concept of acceleration is the idea of how fast or at what rate your motion is changing. So, if your velocity is your distance traveled over an average amount of time, average distance over average time, then your acceleration is your average change in velocity over that same amount of time. So if an object's moving at a constant velocity, it has an acceleration of 0. If it is at any time speeding up or slowing down, it has some form of acceleration, positive or negative. But whether it's positive or negative doesn't matter. Whatever it is non-zero. Now, let me reset this real quick. I'm not going to turn on my forces. I don't want to see them. All I want to see is what the velocity, the speed, and the acceleration is. Now, notice this is a speedometer. It does not tell me the direction of motion, so I will fill that in as we go. So I'm also want to eliminate friction here, so we don't have that mucking up our results. So let me pause this real quick as I apply. So I'm going to get us started in what is a little more traditional, a setup. I'm going to be applying a force to the right, so in the positive direction. I should see a positive acceleration, and we should see a positive velocity. And sure enough, that's the case. Acceleration is positive. We can see it's here, so it means it's moving towards the right. And the speed is following quickly behind it. Now, once we reach the maximum speed of 40, that's the most amount of speed that the guy pushing it could reach. The object moves. Acceleration has now dropped down to 0, but velocity is the same. And so, while this is telling me the speed is 40 meters per second, speed is directionless. It's just whatever direction you're currently moving. I would specifically say that this is 40 meters per second in the positive direction or to the right. Now, because there's no friction and no air friction, this will conceivably go forever. This is into one of your Newton's laws. A body in motion or at rest stays at motion or at rest until acted on by an outside force. So this is exactly what we're seeing here. There's no outside forces acting on this. This object will go forever. But we don't want it to go forever. Now, I want it to slow back down. I want to get it back to its original speed, which was 0. So I'm going to apply a force in the opposite direction. Notice the force has a negative value, and you'll see as the speed goes down, the acceleration itself also a negative value. Now it goes down really fast. Now, before we reach the end here, I'm going to increment this down a little. So down to 100 newtons. Drop the acceleration down, but still negative. Now, notice what's happened. As soon as I keep applying it, it just keeps going in the opposite direction. So once it hit 0 and I kept applying a force, the object just started moving in the opposite direction. Now, we're going to get the same situation, maxed out at 40 meters per second, but this time it's 40 meters per second in the negative direction, or to the left. Acceleration 0 because we're no longer pushing. We'll go from here. Now, this is where the confusion comes in. Normally, most people think that you have to make something speed up, you have to apply a positive acceleration, but currently the object is moving to the left, and that's the negative direction, and I need to get it to slow down, so I have to push it towards the right, which is the positive direction. So in this case, I'm going to have to apply a positive acceleration to make this box slow down. And sure enough, 6 meters per second positive gets it to slow down until it hits 0, and then eventually it will now move in the positive direction. So let's summarize this pretty quickly. So this is just a brief concept of this. If you want an object to accelerate and pick up speed, so you want it to gain velocity, the acceleration it experiences has to have the matching direction of its current velocity's direction. So another way to think of this from the positive and negatives is if I'm moving in the positive direction and I want to pick up speed, I have to apply an acceleration in the positive direction as well. If I'm moving in the negative direction and I want to pick up speed, I have to apply acceleration in the negative direction. So I would have to apply a negative acceleration. If you ever want to slow down in this left-right positive-negative motion, then you have to make sure that your acceleration is in the opposite sign or opposite direction of your current velocity. So for this example, if I'm pushing the object to the right, then I have to apply an acceleration to the left to get it to slow down. If I'm object is moving to the left and I want it to slow down, I have to apply it to the right. Okay? So keep this in mind as you answer questions about acceleration or velocity, specifically about acceleration, that whether the object is speeding up and slowing down doesn't depend on whether the object's acceleration is positive or negative. It depends on if that acceleration, positive and negative, matches the positive or negative of the velocity. Hopefully this will help clarify some of the common misconceptions that students usually have on this topic. If you do ever have any more questions, feel free to contact me and we'll go over this with a couple of other examples and a few more details.